Right, it is good to see everybody. So a couple of quick announcements before we get going. Remember, tomorrow by the end of school is the deadline if anybody's wanting to turn in their extra credit. In order to get it, you got to get 4 out of the 5 questions right. I do have a few extra copies if anybody would like one. And then probably the most important thing, I'm going to keep mentioning it, Blue Book. Please make sure that you can get onto Blue Book through your Chromebook. Remember, on Tuesday, you can't let it autofill. You need to know your username and your password. And speaking of Tuesday, we are days away. How are we feeling? Are we feeling good, optimistic, in the middle? Okay, all right, that's okay. Remember, there's still plenty of time left. You've got a lot of resources that I provided you. I'm going to give you another one today. If you're having any trouble, come on in. But think about if you find yourself not remembering one of the concepts that we've talked about throughout the year, think about the strategies that we've discussed when it comes to the multiple choice exam. What can you do to eliminate answers? Okay. Remember, give yourself credit. You know more than you think you do. Okay. You're going to be fine. You'll walk into that test, okay, believing that you can do well, and you will. Okay. Well, let's go ahead and get to it. So today we are talking about FRQ number 4. So what can we expect? Okay, well, it's going to be symbolic manipulations, and it's going to be using several functions. More than anything, this is really just a skills test. Are you able to work with different functions? Can you solve different types of equations? Of course, there's no calculator, so you're going to want to show your supporting work on each of the parts. But this right here, it could give you an exponential, logarithmic, trigonometric, or inverse trig. Okay, all of those are very, very likely to show up on this 4th one. Now, 2 parts of the question require students to solve equations using given functions. The 3rd part of the question requires students to rewrite given function expressions in equivalent forms. That's referring to the identities. So it's going to give you some kind of trig expression, and you've got to rewrite it however they ask you to go ahead and do so. Now, we're going to do this 3 things. Number 1, determine the exact values of expressions that can be obtained without a calculator. Number 2, use algebraic methods and rules for exponents and logs to combine terms. And 3, again, show the work that leads to their answers in each part of the question because there's no calculator. All right, well, let's go ahead. Let's break down this last question. So this is an evaluate and solve type of problem. It's going to be very straightforward. Like I said, it's skills practice. Okay. Now, every FRQ4, you're going to have this exact box at the very top. It's going to give you the same set of instructions. So I've highlighted a few things here. Unless otherwise specified, the domain of a function, f is assumed to be the set of all real numbers x, for which f of x is a real number. Solutions to equations must be real numbers. Combine terms using algebraic methods and rules for exponents and logarithms. So basically, here's what this comes down to. If you come across an expression that you could simplify without a calculator, you absolutely want to go ahead and do that. Like, let's do a few of these. What is log base 2 of 8? 3. 2 cubed is 8. Okay. What is cosine of pi over 2? Oh, it's not 1. 0. There we go. But that's the type of thing. If you should be able to simplify or solve it without a calculator, do so. If you come across something that you would need a calculator to actually get the answer, then don't worry about that. Like if you ended up with like the log of 37, you know, 10, right off the top of your head, 10 to what power would give you 37, you would want to approximate that in the calculator. So you would leave it as the log of 37. Does that make sense? Okay. All right. And then once again, can't emphasize this enough, show the work that leads to your answers. Okay. Supporting work will be required to go ahead and get that point. All right. Now, overall, simplify everything. Now, we're applicable. Answers that have not been evaluated according to bullets 2 and 3 in the directions do not earn the point. Okay. Now, here's what's interesting. Rationalizing a denominator is not necessary. So if you end up with an answer that could potentially be, I don't know, 1 divided by square root of 2, you could leave it as that, and it would be perfectly fine. Okay. So the first 2 functions you're going to be given, most likely, one of them is going to be exponential or logarithmic. Very, very high probability of that happening. As you continue to go through here, the second set of functions you're going to be given, one of these is usually going to be trigonometric. What we know for certain, neither one of those is going to be a polynomial. Okay. Now, when you're dealing with a log expression, I like to go ahead and put parentheses around my argument. If you choose not to do that, it's perfectly fine. Whether you put the parentheses or not, it has no bearing on whether you would get or lose the point. Okay. As you work through, the use of a variable other than x is acceptable. That's not a problem. Now, coming down here to the last part, you're going to have to solve some type of equation. The one we're going to do today is going to turn out to be a trig equation, but the instructions do say find all values in the domain of M. So when we're asked to find all values, all solutions, remember, you want to go ahead and rewrite your answer as an expression. If you're solving an equation that involves tangent or cotangent, remember, we would add plus pi n at the end of your answer. Okay. If we were solving for sine, cosine, cosecant, or secant, then you would add 2 pi n at the end. And remember, that relates back to the period for each one of those functions. So the way it's going to work, if you were just to go ahead and give one exact answer, you would get a point for that. But if you went ahead and rewrote it as an expression so that you could get all the values of x, that's where the second point would come from. Okay. So pretty easy breakdown. Are there any questions about any of this? Okay, so here's what we're going to do today. I'm going to give you 20 minutes. You're going to now run through this problem number 4. Okay, you're going to go ahead and show your work and put your answers on this page right here. At the end of the 20 minutes, you'll pass it in, and then we'll talk about the problems themselves if you had any difficulties with them. Okay, now I'm going to let you work together on this. Okay, but while this is the last grade of the year, well, that's kind of sad, right? It is sad. I'm going to wipe away my tear. Okay, exactly. Anyway, don't just go to who you think is going to be able to help you get the right answers. If you're not understanding something, ask somebody. Like, hey, how did you get that answer? What did you do? Because we want you to be as prepared as possible when Tuesday rolls around on the real test. Okay. Now, for anybody who may be listening to this video, we're going to have basically a 20-minute pause. So if you want to speed it up or skip or even try it yourself, there you go. Okay. 20 minutes. Yes. Sure. Yeah, I mean, you got the same problem right there. Yeah. The desk is wet. Oh, I wonder if somebody just had a drink during the last period. There's hand sanitizer right there. We can just wipe it off. I can absolutely confirm that's not drool because nobody would ever fall asleep in math class. No, I'm here. It's not. Yes, I would. If I would either put x equals, or in that case, it's just an equation. So I wouldn't put g of x equals. Hmm. Remember that any restrictions, you don't have to put that. Yeah, it's that curvy E.
You're telling me the wrong things.
Yeah, you put it into a fraction because the additive property says that those two multiply together, and then it's actually
2 squared plus 2 pi.
so is it
Alright.
what?
What'd you get?
X nine, but I don't know.
It has to be we're on just I voted for
X nine because
I declare that
our
cow
property.
is good.
Got the 9 in front of
Pre-cal's bad for who?
I said Dan.
Oh,
you're
pre-cal's good for everybody.
check with this.
No, 3 cow's good. This is good.
It's just banned.
What question?
Oh,
That will explain it very well. You know FRQ are banned?
I remember when they first came out, there was concern about them hearing and potentially repeating classified secrets. Do they even still make those things? I don't know.
But they banned it for COVID.
Yeah.
I love this so much. Oh, this is our property stuff. So there's like secant squared plus 1 equals. Or no, tangent squared plus 1 equals secant squared. I don't know what that's. Oh, 1 minus sine squared is cosine squared. So it's going to be cosine squared of x over sine of x. And cosine over sine is cotangent, right? Yeah. But we can, it's cosine squared. Hold on. Let me secant of x is the same thing as 1 over cosine x. And then, you multiply, you get
Okay,
cosine
just under 10 minutes.
over sine x, cosine x, right? And then you cancel that one out. Cosine x over sine x equals. Is that
You don't want to work with anybody?
Yeah.
Sure.
Y over x, right? Tangent equals x over y. So it's 1 over tangent x.
Is he okay?
Yeah, he's just stuff like X.
Okay.
So
Oh, don't tell me that. Then I got worried.
part of
Crazy.
it does. That one was fun. What? I don't understand. So it's all the properties of trig. So there's like, I started out by doing this, I forget what it's called, but cosine squared of x plus sine squared of x equals 1, right? Which means that 1 minus sine squared x equals cosine squared of x. So we have that as our top one over sine of x. And secant x is ugly with all this stuff. I want to make them as similar as possible. So secant of x is the reciprocal of cosine x. So that becomes 1 over cosine x. And since you're multiplying them, you get this, and it's really nice because you can get rid of that extra cosine up top like that, which leaves us with cosine x over sine x, which is the same as cotangent x. And they want our answer to include tangent, so just 1 over tangent of x.
Oh, are you?
Guys. You're not. Like, yeah. But I have to like push my Yeah. And then this last one's really hard. The last one? Well, did y'all get the first log 10 x6 over x? Wait, I'm looking at I just combined these. Wait, where? Shoot, you're right. Okay.
Why'd you make that 9?
It's 16x.
No, but when you put it as a power, it's still up.
Yeah, because it's still dividing.
No, you can, okay, here's my train of thought. Okay, since this is, the 9 is multiplying these guys. Right?
Yeah.
So it's gonna
But have we done it like that before?
well, you go left or right, so what? It's multiplying up first. So would that be the 9 first? Well, wait, I don't know.
Shoot, bro. I feel like we've done a similar problem before, and it wasn't, like we didn't flip it, because we're already dividing. So, would it just be like, if we backtrack a lot, and we don't try to combine steps, would we just divide and then have like 9 log 10 of x on the bottom, and wouldn't that just be like...
Yeah, maybe ignorance, but if it is that, what would that look like with the
I got like 16x over x to the 9. Oh, I meant to the 7. I added it wrong. To the 7. I think you're right. Yeah. And then you divide that. Yeah. So then you get log 10. I think that's right. I don't think it's that. Let me see. Like
Stu?
I think that's kind of like Stu wants to go. That was like had a little bit of too. So I use properties here.
So right now we're working on number 4.
It's the same as that squared. So we'll have that up top.
Okay, just under 4 minutes.
Which cosine x over sine x equals cotangent x, and then they want tangent in the final answer, so you're just gonna do that. I think B1 is log 10 of 16 over x squared. So I think it's just like, I don't know, trying to which is so weird. Okay, y'all. The first one is 16 over x squared. Log 10 of 16 over x squared. We already went over b. Has anyone done? I'm starting. I heard that's the worst one. Log 16 over x squared. I'm worried about that one.
Not any extra ones. Actually, the breakdown that I have here, it has the problem on it. Mm. The blank paper? Yeah, I got that right here. Here we go. 2 minutes.
I mean, can you see what we did on that one though, where you put it? That's the one I
30 seconds.
Oh my god. Guys, we're putting pi over 8 plus pi towards wait. Pi over 8 plus pi towards and it's like so you set it up like that and then you flip it in the same way we did that one other problem where it's cosine 0 equals 2x. And like
All right, that is 20 minutes. Go ahead and make sure your name is on it. Let's pass it to the front, please.
oh my god.
Yeah.
There's
Right.
no way
Is
that's
this
right.
still like
Thank you.
yeah.
Take that. Thank you, sir. Thank you. Thank you, thank you, thank you.
No, I
Okay, thank
I
you.
started it and I forgot the double angle and I screwed up.
Thank you, thank you, thank you.
We don't turn this in.
No, that's yours. That is yours.
I just hope you know that's a 4 at the bottom.
That's a 4 at the bottom. Okay. All right, do I have them all? All right, let's talk about it. Okay, so AI, okay, it says solve g of x equals 10 for the values of x in the domain of g. So all I want to do is take function g the exponential, e to the x plus 3, and I want to set it equal to 10. Okay. Now, because it's a log, you can do a couple of things. You could take the log of both sides, or what a lot of people have been doing today is just rewriting it as into a logarithm. So since it's base e, that's the natural log of 10. And remember, what is a log? It's a power. So whatever log expression you write, it has to equal the power that you're working with. And since we're just solving for x, I'll subtract the 3. So the natural log of 10 minus 3 is equal to x. So that you would need a calculator to approximate, so we would just leave it as is. Okay, how'd we do on that one? Okay, it's good to go. Okay, so that would be 1 point. No, remember, like if I have, like in this case, you know, I put 10 in parentheses, but if you would just put log of 10, perfectly fine. They're not going to count off for that. Okay, so let's take a look at A2I. So h of x, we want to take arc sine. What does it mean, arc sine? That's the inverse. Okay, so I'm going to go ahead and just rewrite it in the old-fashioned notation. So sine inverse of x over 2, and they want me to set that equal to pi over 4. Okay, so what I want to do here is I'm just going to rewrite this equation as sine and not sine inverse. So that means I'm going to switch these two quantities. So sine of pi over 4 would equal x over 2 because I can evaluate sine of pi over 4. All right, so if I come over here, pi over 4 is in the first quadrant. So there is my terminal side with my angle. So I'm going to use that to create a right triangle. Remember, we're on the unit circle. What were the two identical lengths for this triangle? Root 2 over 2. So this is root 2 over 2, root 2 over 2. Now, because I want sine, we want the y value. So square root of 2 over 2 equals x over 2. And then we've just got a proportion, so I can cross multiply. If 2x is equal to 2 root 2, well, then x should equal root 2. Okay, how did we do on that one? Did we get the second point? Okay, so there we go. All right, now we're moving on to B. Okay, so the first part, it says rewrite J as a single log with base 10 and without any negative exponents. All right, so here we're just wanting to condense it. So I'm going to start from the left side and work my way right. What do we do with logs that are separated by addition if they have the same base? We multiply. So this is going to be log base 10. So 8x to the 5th times 2x squared is 16x to the 7th. Now, I'm going to go ahead and not condense the remaining portion just yet, so I'm going to have minus, but I am going to go ahead and make this coefficient a power on that argument again. So I'm going to say minus log base 10 of x to the 9th. Well, now what do I do with two logs that are separated by subtraction? We divide with 16x to the 7th going in the numerator because it's written first. So log base 10 of 16x to the 7th over x to the 9th. And then all I want to do is simplify anything that I might be able to. So I can cancel out 7x's with 7x's below. So we should be ending up with log base 10 of 16 over x squared. How did we do on that one? Did we earn our third point? Okay. Very cool. Very cool. Okay. Well, B2I. So rewrite K as a single term involving tangent. So this has actually kind of confused people throughout the day. It's not saying that your answer is going to be tangent. It's just going to involve tangent. So it could be negative tangent. It could be tangent squared, etc. So let's see what we got. So this trig identity expression, one of the strategies we used, if you were ever stuck, rewrite everything in terms of what? Sine and cosine. So I would probably start with this secant right here. So I'd go ahead and say secant is the reciprocal of cosine. Then at the same time, does anybody notice anything about the other fraction? There's a Pythagorean identity. 1 minus sine squared, that is cosine squared of x. There you go. Finally, let me write the 2. And then this is over sine of x. So what does that allow me to do? Okay, we can cancel out a pair of cosines. So what is cosine over sine? That's cotangent. But now remember, it said it wanted it involving tangent. What's the relationship between tangent and cotangent? They're reciprocal. So I would say this is 1 over tangent of x. There we go. Did we get the fourth point? Okay. Well, from what I heard of the conversations, it was part C that was causing people some issues. Let's take a look and see what we got here. All right, so we've got function m, cosine inverse of tangent of 2x. Find all values in the domain of m that will yield an output of 0. So we want to take this function, cosine inverse of tangent of 2x, and I want to set it equal to 0. Now, we're going to go ahead and do here exactly what we did back in A2I. We're going to rewrite this instead of cosine inverse. We're going to write it as a cosine equation. So that means I'm going to go ahead and switch those quantities, even though that one's a trig function. Perfectly fine. So I'm going to have cosine of 0 should equal tangent of 2x. Now, we can evaluate this ourselves. What is cosine of 0? Okay, that is just 1. So cosine of 0 is 1. This equals tangent of 2x. See, now all I got to do is solve this trig equation. Now, forget about the fact that it's 2x. Let's just solve it like it was a normal equation. This is when I go to my grid. All students take calculus. So where is tangent positive? 1 and 3. So I'm going to draw triangles in 1 and 3. Okay. Remember, this isn't a fraction, so I can make it a fraction. Tangent is y over x. So we have, bless you, the vertical y, the horizontal x. Now, in the third quadrant, they would both be negative. Okay. What's the hypotenuse? Square root of 2. So what kind of triangles am I looking at here? They're 45, 45s. So that means this answer right here, the first one is pi over 4, and then I'll use that other triangle to get my second answer. Now, here's how the points are going to work on this problem. Okay, if I just go ahead and give one specific answer, that's going to give me 1 point. Now, this is normally where I would go ahead and say, you know, x equals pi over 4. Remember, we always have to rotate from standard position. But it's not x. Now we want to go ahead and bring in that 2x. So if I go ahead and say 2x equals pi over 4, divide by 2, that's going to get me 1 point. Okay, because I gave a specific solution to the equation, but it wants all of the values. So I'm going to go ahead, before I divide through by that 2, I'm going to turn this into an expression. Because we're solving specifically for tangent, I would say plus pi n. Why did I choose pi instead of 2 pi? Tangent has a period of pi, not 2 pi radians. So now when I divide through by 2, x is going to equal pi over 8 plus pi over 2n. That would give me all the solutions that I'm looking for. Now, normally at the end of these, we'd go ahead and also say, you know, n is an integer. You don't have to put anything like that. No restrictions. It's not going to worry about it. Okay. Now, here's the thing. We're also not done because we have a second triangle. So I could start here and rotate around. So what's pi plus pi over 4? 5 pi over 4. So now I would do this again. I would say 2x equals 5 pi over 4, again, plus pi n. Let me go ahead and get this out of the way. Now, I think you kind of lucked out on this one. You'll see why in just a second. Let me go ahead and divide through so that here would be my second solution. X equals 5 pi over 8 plus pi over 2n. Okay. Now, this won't happen every time. This one is kind of specific. It's unique because we were solving for tangent. Anybody notice it? When I went and did the first answer, what did I add to it? Multiples of what? Pi. Well, look at these two answers right here. How far apart is one hypotenuse from the other? So this answer would actually provide me every answer that this one would give me. So technically, we don't need to write that. Now, let's say you didn't realize that. What if you went ahead and put it? Is it going to be okay? Yeah, absolutely. They're not going to count off for that. Now, that's not going to happen every time. If you were dealing with something like sine or cosine, you would absolutely want to go ahead and write both your expressions. Okay. But because I went ahead and included this, so I found all the values, that would get me my sixth and final point. Okay. How are we doing? Well, see, it's good to see this because now you know what to expect. Now, let me go ahead and do this. Past couple days, we've been talking about FRQs. So I gave you a brand new sheet for part A. So I've got a brand new sheet here for part B. Okay. Remember, I wouldn't take 20 minutes to go ahead and solve this. How many minutes are you going to get to solve number 3 and 4 together? 30. You're only going to get 30 minutes. So within 30 minutes, you've got to solve a question like number 4 and one like number 3 that we did yesterday. So you have to budget your time. So I've got another set of examples right here for you. We have not worked these problems together. And if you go ahead and take a look at College Board, those FRQs that I assigned, they're not coming from those either. These are an extra set. Okay, so I would encourage you, please, please look through these. Or at the very least, take the 2 FRQs that you feel you need the most practice on. Go ahead and practice, especially those where there's writing. Okay, so if you were to go ahead and take a look at the website right now, it has the full key to what I'm passing out. Hey, everybody. Okay, just please be quick because you came in really late. Okay. All right. So remember, folks, we've only got, a few days left before you take your exam. Okay. You're going to be fine. I know it can be, very stressful, very overwhelming. Okay. You've put in the work. We've talked about all this material. You know what to expect. You know more than you're giving yourself credit for. Okay. I absolutely believe, I would bet every person in here can go take that test and come out having passed it. I'm absolutely serious. I wouldn't say that if it weren't true. Okay. Even if you run into a problem with one of the concepts, let's say multiple choice, think about some strategies. What did we talk about that can still help you get the answer even if you don't perform the computations? Okay. Take your time, budget yourself, take care of the problems that you know for sure first, then go back and spend time on those that are going to be a little lengthier or more challenging. Okay. Are there any questions?